The question asked the equivalent hexadecimal number of the signal, and this signal containing 7 bits. So let's find out how many bits actually here. So here 1 bit, 2 bit, 3 bit, 4 bit, 5 bit, 6 bit and 7 bit. So here actually 7 bits available within the signal. Now, of course, the very important task is to write down in binary form. So high means 1, high means 1, low means 0, 0, high means again 1, 1 and 1, right? So the binary value of the signal is 1, 1, 0, 0, afterward 111, right? So hexadecimal actually 2 to the power 4 means base is 16. It means 4 bit. So we have to start from the right. So this is 4 bit and again this will be 4 bit. So we can add here another number. So let's write down here 0. It actually not change the value or anything. So we can actually write down 0 at the very left of the number. So 0, 1, 1 represent 7 and 1, 1, 0 represents 6, right? So the hexadecimal will be 67 of the signal. So this is 67, pardon. So in this signal, we have to convert from the signal to octal value, and the signal is 8 bit. So here will be 2 bits, here will be 2 bits, here will be 2 bits, and here will be 2 bits as well. So all together here actually 8 bits, right? So this is high mean 1, 1, low means 0, 0, high means 1, 1 and 0, 0. So the value of the binary form will be 1, 1, 0, 0, 1, 1 and 0, 0. So octal means 2 to the power 3. So 3 will be the number of bit, and of course 2 to the power 3 means 8. It's base number. So 3 bits for the octal value. So this one, afterward this one, and again this one. We can actually write down 1, 0 here at the left. So it actually not change the value. Anyways, so this will be 3 and this will be 1 and this will be 4. So the signal represents the octal value will be 341 octal value. Hope you understand. The question is, what is the equivalent decimal value in the figure contain 4 bits? So here is the signal or figure. It says here is 4 bits. So this one high bit, it means value will be 1, it will be 0 and this will be 1 and of course this will be 0 as well. So the value will be 1, 0, 1, 0. So this is the binary value of the signal. And 1010 4 bit value contain the decimal value will be here, this one. So 1010 4 bit, it means the value of 1010 will be, decimal value will be 10. So this is the binary value, and the value of binary 1010 decimal value will be 10. In this question, what is the equivalent hexadecimal? So this question asked for hexadecimal value. So hexadecimal will be 4 bit as well, and the base will be 16, right? So 4 bit, the signal, this is high value. It refer the value of high will be 1, low will be 0, high will be 1, and this is 0. It means this is 1010, right? 1010, this will be binary. So what is the value of 1010 for hexadecimal. So this will be 10, right? For decimal. For decimal 10, it will be A. So the hexadecimal value will be A. So in this signal asked for the decimal value. So this signal, the high value is 1, this is 0, this is 1, this is 1, because here actually asked, this is 8-bit signal, that's why here actually 2 point. So 1 and 1, again 0, and again here will be 1, 1 and 0. So how many bits here? 1, 2, 3, 4, 5, 6, 7, 8. So we could write down 1, 0, 1, 1, 0, 1, 1 and 0. So if we apply 8-4-2-1 theory, so indeed, let's change the color of the pen. So here will be 1, and then 2, then 4, then 16, then 32, then here will be 64, and then 182. If we apply 8-4-2-1 theory, let's try like this: 8-4-2-1. As this is 8-bit, so it should be 16, afterward 32, then 64, and 1 to 8. So this is 8-bit, it should be here 1, here 0, afterward 1, 1, and then this will be 0, and then 1, 1 and 0. It means we have to add up 128, 32, 16, 4 and 2. If we sum up this value, we'll get 182. So this will be the decimal value of the signal. Let's try again. Let's clarify the sum up: 128, 32, 16, 4 and 2. So if we sum up these numbers where 1 is, so we'll get the value 128. In this signal, how many bits here? Here are 6 bits, right? So the value of high bit is 1. Here are 2 bits, so this will be 0, this will be 0, and of course here are actually 3 bits. So this one high, this one high, and this one high. So the value of the signal in binary 1, 0, 0, 1, 1, 1, right? Now if we apply 8-4-2-1, so 8, 4, 2, 1, here actually 4 bits. For 5 bits, it will be 16 afterward, and then 32. So 1, 2, 3, 4, 5 and 6 bits, right? So here 1 for 32, and here will be 0, 8-bit also 0, and this one will be 1, 1 and 1. So we have to sum up 32, 4 and 2 and 1. So this is 32, add 4, 36, 38 and 39. So it will be 39 in decimal value. In this signal, how many bits here? Here are 6 bits, right? So in this question, here are actually 7 bits. Indeed, this is high, so this will be 1, and here should be 3 bits. All these 3 bits are 0 of this signal, and here as well 3 signals. So all these 3 signals are high, so this will be 1, 1 and 1. So the binary form will be 1 0 0 0 1 1 1. Right now this 1 belongs to 64 and 32, 16 and 8. All of this belongs to 0, and afterward 4 to 1. So we have to sum up 4, 64, 2 and 1. For this signal, we have to find the equivalent octal value from the signal, and the signal actually containing 4 bits. So we can see this is high, then low, then high, then low. So there are actually 4 bits, right? So for high bit or high signal, value will be 1, then 0, then 1, then of course 0. So the binary number or binary form from the signal, we have 1 0 1 0. For octal, obviously each of the octal number containing from the binary will be 3 bits. Why? Because of 2 to the power 3 is equals to 8. 8 is the base number, so we have to take 3 bits for each octal number. So of course this is the first one, and afterward here. So there is actually no value, so we could write down 0. Actually before 0, if we write down any number, not changes or not impact any value. So anyways, this will be 1 and this will be 2. So this is the octal number of this value. For this signal, we have to find out the hexadecimal value. And the very important thing is how many bits available within this signal. That is actually 8 said by this question. So we have to split this signal, or we have to find out 8 bits from this signal. So let's 1, 2, 3 and 4, right? It means here 1, 2, 3, 4, 5, 6, 7 and 8 bits available here. So high value 1, high 1, 0, 0, 1, 1, 0, 0. So the binary form will be 1, 1, 0, 0, afterward 1, 1, 0, 0. So hexadecimal containing 4 bits. So of course this is one number and here will be another number. So from the table of decimal binary form table, here 1100, 1100 is this one, right? 1100 for 4 bits. So this will be 12. But in hexadecimal, 10 become A, 11 become B, and this will be C. So this will be C and C. So this is the hexadecimal value. So we have to find out the value of hexadecimal and the octal for this signal where 8 bits available. Right? So for high bit 1 0 1 1 0 1 1 and 0, right? Indeed, what we have 1 0 1 1, then 0, then 1 1 and then 0. Let's start with the hexadecimal one. So for hexadecimal, this will be 4 and here will be 4, right? For hexadecimal 0110, it means this value, which is 6, and 1011, 1011, it represents 11. It means B. So the hexadecimal will be B6. So B6 will be its hexadecimal number. For octal, we have to count 3 bits. So 3 bits here, 3 bits afterward here as well. We can add up here 0. It actually not changed as we said a couple of times. So 110, 110 means for 3 bits, by the way. That is very important things. So for 3 bits actually 110 represents 6. So this is also 6, and 110 again 6, and 10 means 2. So this is its octal value. The question asked for decimal value of this signal, and this signal containing 7 bits. So the high value, of course, 1, and here 1 2 3, and here as well as 3 bits, right? So 3 bits, 3 bits, and 1 bit. So altogether is 7 bits for this signal. So this will be 0, 0, 0, 1, 1, and 1. So altogether 7 bits. So how it's look like the binary form is 1, 0, 0, 0, then 1, 1, and 1, right? So here are 7 bits. Start with the, let's change the color. So here, of course, 1, afterward 2, then 4, then 8, 16, 32, and 64. So what we have to sum up? Of course, 64 because of this 1. Of course, 4 because of this 1. Of course, 2 because of 1 and 1. So if we sum up these 4 numbers, we'll get the very important number for Bangladesh, that is 71. So this is the decimal value of the signal, right? Why we are not taking this 0? I mean, not 32, not 16, not 4, because this belongs to 0. That's why we are not sum up with our number. So we have to sum up the number 64, 4, 2, and 1. Then the final value for the decimal value is 71.